Hello everyone. Today we will discuss about phase difference between direct path and a ground reflected path. This is also called as two-ray model. Also called two-ray model. So we will calculate here. Hello everyone. Today we will discuss about phase difference between direct path and ground reflected path. Direct path and ground reflected path. This model is also called as two-ray model. Two-ray model. So here we will calculate the phase difference between two paths, that is one is direct path, direct wave, that is direct wave from the antenna to the mobile unit, and the other is reflected wave, that is reflected wave from the antenna to the mobile unit, reflected wave. So we will calculate the phase difference between these two paths, that is d1 and d2, that is directed path and direct wave and reflected wave. You will find out the phase difference. So before finding the phase difference between these two paths, direct wave and reflected wave, here we will consider the height of the antenna h, and the mobile unit antenna height as h2. So the direct wave which is coming from the antenna to the mobile unit, the direct wave, its height is considered as h1 h1 plus h2, because we will consider the height of the antenna and also the height of the mobile unit, phi value. And for reflected wave, we will consider the height as h1 minus h2. That is, the reflected wave from the antenna is again reflecting to the mobile unit at an angle of theta. So here we will remove the height h2. Remove height h2. So from the height h1, from the antenna height, I am subtracting the h2 value, mobile unit height. Okay, this is the table. Hello everyone. Today we will discuss about phase difference between direct path and reflected wave path. That is also called as two-ray model. The phase difference between direct wave and reflected wave. So before we calculate the derivation part of, before we calculate the phase difference between direct wave and reflected wave, we will consider this diagram. See, we had already learned the ground incident angle and ground elevation angle in previous classes. In ground incident angle and ground elevation angle, we had calculated theta value. That is, for reflected wave, we had calculated the theta value as tan inverse h1 plus h2 by d. Here h1 is height of the antenna and h2 is height of the mobile unit. So to calculate the theta, we had written that theta is equal to tan inverse the height of the antenna h1 plus as it is reflected back again to the height h2, we will add this h2, that is tan inverse h1 plus h2 by d. This is the value we had calculated the theta in ground incident angle. And for ground elevation angle, that is for phi value we had written as phi is equal to tan inverse h1 minus h2 by d. h1 minus h2 by d. It means this direct wave is coming directly to the mobile unit antenna. Here we will remove the height h2. We will remove the height of the mobile unit h2. So we will write the height of the antenna h1 minus, we will remove the mobile unit height h2. So we will write phi is equal to tan inverse h1 minus h2 by d. Clear? These are the values we had learned in ground incident angle and ground elevation angle. That is theta value and phi value. Now for this diagram, we will calculate the phase difference. The phase difference between this direct wave D2 and reflected wave. So before calculating the phase difference, we will write the expression, that is the received power PR at the mobile unit. Mobile unit is given by, that is the received power PR to the mobile unit from the antenna. It is given as the expression PR is equal to P naught into 1 by 4 pi d by lambda whole square modulus of AV e power j del phi whole square. This is the received power equation to the mobile unit. From this received power equation, we will calculate the phase difference. The phase difference between direct path and reflected path. Now we will write the terms, what the terms indicate. Here PR is the received power to the mobile unit. P naught indicates the transmitted power at the cell site. And here AV is the reflection coefficient. Here we will take the reflection coefficient AV equal to -1. AV is equal to -1 because here we are taking the height of the antenna. Height of the cell site antenna is low, and due to this we are having only small incident angle. And in that particular basis, we will take the reflection coefficient. Reflection coefficient AV is equal to -1. And lambda value. Here lambda is the wavelength, D is the distance from cell site antenna to the mobile unit, and beta is equal to phase constant, which we will study further. So here I had written beta value. So remember, we will recall this beta value again. And here mainly we will study about this del phi. In the expression we had written e power j del phi. Here del phi represents the phase difference between direct wave and reflected wave. That is the phase difference between D1 reflected wave and D2 direct wave. You will calculate the phase difference. Now what is the topic? What is the topic we are discussing here? Phase difference between direct path and reflected path. In which symbol it was represented? It was represented with the symbol del phi. So here we have to finally calculate the del phi value. Del phi value from the above expression 1. So in the above expression, del phi value, here we will calculate this del phi value from the expression 1. Now how to calculate this del phi value, phase difference between direct wave and reflected wave. So coming to the derivation part, now I will take the second part of this equation. Only I will take the second part of this equation, because the del phi, e power j del phi is represented here in the modulus value. I will simplify the second part, modulus of 1 plus AV e power j del phi, and substitute the value again in this equation 1. So we will start the equation. So coming to the equation 1. See here, PR is equal to P naught into 1 by 4 pi d by lambda whole square modulus of 1 minus e power j del phi. Here I had written minus value. Why I had written minus value? Because I had taken the reflection coefficient as -1. AV value -1. As I had taken the AV value is equal to -1, it becomes minus value. So 1 minus e power j del phi. 1 minus e power j del phi. Now here we can observe the expression, that is it is in the form of e power j theta. It is in the form of e power j theta. We know that e power j theta is equal to cos theta plus j sin theta. Now substitute this value. So PR is equal to P naught into 1 by 4 pi d by lambda whole square modulus of 1 minus, I will write this e power j del phi as cos del phi minus of j sin del phi. Here the minus is given to the both cos theta and sin theta, as AV value is equal to -1. So I got the expression modulus of 1 minus cos del phi minus of j sin del phi. Now I will take this 1 minus cos del phi as one term, A value, and j sin del phi as B term, second term. I will consider this as first term and second term. Now from this expression, we had formula from the algebra, that is modulus of a minus jb, or modulus of a plus jb is equal to square root of a square plus b square. So here in the equation 3, I had the modulus of 1 minus cos del phi, which is represented with A, and minus of j sin del phi. This j sin del phi is represented with B. So it is in the form of modulus of A minus JB, which we can write as square root of A square plus B square. So I am simplifying the equation 3. Equation 3, this modulus part. Now simplifying this modulus part in the equation 3, that is modulus of 1 minus cos del phi a term minus j sin del phi b term, I will write in the form of square root of a square plus b square. So modulus of square root of 1 minus cos del phi, 1 minus cos del phi a square plus j sin del phi, that is plus b square represents sin del phi whole square, modulus whole square. Now expand this equation, that is 1 minus a minus b whole square formula. Apply a minus b whole square formula to 1 minus cos del phi whole square. That is 1 square minus 2 into 1 into cos del phi plus cos square del phi plus sin square del phi. Now we can write this cos square del phi plus sin square del phi as 1. That is 1 minus 2 cos del phi plus 1. So we get 2 minus 2 cos del phi modulus square. This modulus square and square root gets cancelled, and we get 2 minus 2 cos del phi. If we take out 2 common, then we can write it as 2 into 1 minus cos del phi. Now substituting this 2 into 1 minus cos del phi in equation 3. Why we are substituting this in equation 3? See, come here. In equation 3, I had taken the second part, modulus of 1 minus cos del phi, represented as A, and minus of j sin del phi, represented as B. I had derived this part, simplified this part in third equation. So I am substituting this simplified expression in the second part, that is in this modulus value of equation 3. So now I will get, therefore PR is equal to P naught into 1 by 4 pi d by lambda whole square into 2 into 1 minus cos del phi. We can again write it as P naught into, writing this 2 in the numerator. So 2 by 4 pi d by lambda whole square into 1 minus cos del phi. This is the fourth expression. Now in this fourth expression, I will write this 1 minus cos del phi as 1 minus cos 2 del phi by 2. I will write it as 1 minus cos 2 del phi by 2, so that I will get the equation, that is 1 minus cos 2 theta. I will apply the formula 1 minus cos 2 theta. So to apply the formula 1 minus cos 2 theta, I will write this 1 minus cos del phi as 1 minus cos 2 del phi by 2. So coming to the expression, applying 1 minus cos 2 theta. So we will get 1 minus cos 2 theta is equal to 2 sin square theta. So 1 minus cos del phi, 1 minus cos 2 del phi, here 1 minus cos 2 del phi by 2, we will get as 2 sin square del phi by 2. Now substituting this value in the expression. So I will get, substituting this value in the expression, in which expression? In fourth expression, in the place of 1 minus cos del phi, I am substituting this expression. So I will get P into 4. Here I am multiplying this 2 with the 2. So 4 by 4 pi d by lambda whole square into sin square del phi by 2. Which is the fifth equation. So from this fifth equation, we can observe that we had an value del phi. Del phi represents, del phi is the, we already studied, del phi is the phase difference between direct wave and reflected wave. The topic we are studying, the main heading of this topic is to find out the phase difference between direct path and reflected path. That is, we have to calculate this del phi value. Now we had got the del phi value here. So this del phi value can be written as beta into delta D. Why I had written beta into delta D? delta D represents the difference between direct path and reflected path. Our main topic we are studying, the topic we are studying is phase difference between direct path and reflected path. Here delta D represents the difference between direct path and reflected wave. And I had written the phase constant beta value. Phase constant beta value because I am calculating the phase difference between direct path and reflected path. So I had written the phase constant beta and the difference between delta D, that is direct wave reflected wave differences d1 and d2, d1 minus d2. So here beta is the phase constant which is given as 2 pi by lambda, a constant value, and delta is the difference between direct path and reflected wave, that is d1 minus d2. Now I will write this d1. d1 is equal to h1 plus h2 whole square plus d square, and d2 is equal to h1 minus h2 whole square plus d square. How I had got these expressions d1 value and d2 value? From the diagram. From the diagram, see here d1 is equal to h1 plus h2 whole square plus d square. So from the coming to the diagram, see here d1 value. This d1 value. To calculate this d1 value, I am calculating this hypotenuse value. So I had written square root of opposite square, h1 plus h2 whole square plus adjacent side d square, h1 plus h2 whole plus h1 plus h2 whole square plus d square. Hypotenuse value. This d2 is taken as hypotenuse value. So d1 is equal to square root of h1 plus h2 whole square plus d square. Similarly, d2 value. To calculate d2 value, I am taking this at dt as hypotenuse value, and this is the opposite side h1 minus h2, and this is the adjacent side. Now I will write d2 is equal to h1 minus h2 whole square plus d square, square root of. So from the triangles I had written the values d1 and d2. Clear? Now I will subtract d1 minus d2, that is difference between direct wave and reflected wave. So d1 minus d2. So delta d is equal to d1 minus d2. So substituting h1 plus h2 whole square plus d square minus of square root of h1 minus h2 whole square plus d square. Now I will write this square root in the form of 1 by 2. That is h1 plus h2 whole square plus d square power 1 by 2 minus of h1 minus h2 whole square plus d square power 1 by 2. I am taking the d square value common. So d square taking the common, that is 1 plus h1 plus h2 by d whole square power 1 by 2, and here also I am taking a d square value common, that is d square by 2, 1 plus h1 minus h2 by d whole square power 1 by 2. Now applying the binomial expression to this term, delta d term, binomial expression. It is in the form of 1 plus nx. 1 plus, it is in the form of 1 plus x whole power n. 1 plus x whole power 1. See, this is 1. And x value here is h1 plus h2 by d and n value is 2. So this is in the form of 1 plus x power n. 1 plus x power n. So writing this 1 plus x power n in the form of 1 plus nx plus n into n minus 1 by 2 factorial x square, so on. So we will consider only the first term and neglect the remaining terms. So delta d can be written as d into 1 plus 1 by 2. See here, this represents n value, and this is the x term. This is the x term. This is 1 plus x whole power n. Here n is equal to 1 by 2. This is n value. So here how I will write 1 plus nx, that is 1 plus n value 1 by 2 into h1 plus h2 by d whole square, x value, minus d into same 1 plus here n value represents 1 by 2, that is 1 by 2 into x term, h1 minus h2 by d whole square. Now simplifying this term, delta d is equal to d plus d by 2 h1 plus h2 whole square, applying a plus b whole square formula, that is h1 square plus h2 square to h1 h2 by d square. Similarly here also minus d by 2 h1 plus h1 square plus h2 square minus 2 h1 h2 by d square. Now after simplifying this expression, you will get delta d is equal to 2h1 h2 by d after simplifying this expression. 2H1 2H1H2 by D. This is the delta D. But what we are calculating, come here. We are calculating del phi is equal to beta into delta D. We are calculating this del phi value, the phase difference between direct path and reflected path, given by beta into delta D. We already know beta is equal to phase constant and is given by 2 pi by lambda. And delta D is equal to, we had got the expression. Final expression delta D is equal to 2H1H2 by D. So we will multiply this beta value 2 pi by lambda into this delta D value. 2H1H2 by D. And we will substitute this value in this fifth expression. That is here del phi value. That is beta into delta D. Now write this del phi value. So we know that from equation 5, del phi is equal to beta into delta D. We know that beta is equal to 2 pi by lambda and delta D is equal to H1H2 by D. Now multiply del phi, that is del phi is equal to beta into delta D, that is beta is equal to 2 pi by lambda and delta D is equal to H1H2 by D. We got 4 pi H1H2 by lambda D. But in the expression 5, we had del square by 2, del phi by 2. We had the expression, see here, sine square del phi by 2. Sine square del phi by 2. So I will divide it by 2 here directly. So del phi by 2 is equal to 2 pi H1H2 by lambda D. Now I will substitute this term in the equation 5. We know that the equation 5 is PR is equal to P naught into 4 by 4 pi D by lambda whole square sine square del phi by 2. So in this del phi by 2, I will write the term 2 pi H1H2 by lambda D. So before writing this del phi by 2 value in this part, we know that sine theta is equal to theta. That is, we can also write as sine square theta by 2 as theta by 2 whole square. So now we will simplify the expression. This fifth expression as PR is equal to P naught into 4 pi D by lambda whole square. Now I will write this term del phi by 2 value 2 pi H1H2 by lambda D. 2 pi H1H2 by lambda D whole square. Lambda D whole square. See here I had simplified this expression. This lambda square I had written in the numerator. So that is 4 lambda square. And I had squared the value. 4 square means 16. Pi square D square. I had simplified the expression. So after simplifying this expression, we will get 4 lambda square by 16 pi square D square. Now squaring the terms. That is 4 square pi square H1 square H2 square by lambda square D square. After simplifying, you will get PR is equal to P naught into H1 H2 by D square whole square. This is the final equation which represents relation between received power and the transmitted power in terms of H1 and H2. This is the final expression which represents the relation between received power PR and transmitted power P naught in the terms of H1 and H2. Where H1 represents cell site antenna height and H2 represents mobile antenna height. In this way, we had simplified the expression. The starting expression we had taken. PR is equal to P naught into 1 by 4 pi D by lambda whole square modulus of 1 plus AV e power j del phi. Here we had calculated the del phi value and substituted the value of del phi, the phase difference between direct path and reflected path. And we had got the expression, final expression as PR is equal to P naught into H1 H2 divided by D square by lambda square. From this expression, if we apply the log terms, we will get the power difference value, between direct path lengths, and also we will get the gain difference, and also gain difference at the mobile antenna. So from the above expression, we can say that we can reduce the relations. Which represents the power difference and gain difference. So the power difference between direct path lengths, between two direct path lengths with respect to cell site is given by delta P is equal to 40 log D1 by D2. Here D1 and D2 are different path lengths from cell site antenna to mobile unit. We had studied in the diagram. This is the power difference. We will get this expression after applying the logarithms to this final expression. So here we are writing directly, that is del P is equal to 40 log d1 by d2, which represents power difference between two direct path lengths with respect to cell side. And also gain difference, we can write the gain difference between two different antenna heights, that is from cell side and mobile unit antenna. The gain difference, it is given as delta G is equal to 20 log h1 dash by h1, h1 dash by h1. And the gain difference with respect to mobile antenna, gain difference with respect to mobile antenna is given by delta G is equal to 10 log h2 dash by h2. Here the gain difference between two different antenna heights at cell site is given by h1 dash by h1. So h1 dash represents the new antenna height and h1 is the taken standard antenna height. Here also h2 dash represents the change in the mobile unit, mobile antenna height, and h2 is the actual height, that is 10 log h2 dash by h2, and at the base station 20 log h1 dash by h1. So from this equation we can reduce, so from this equation we can reduce the expressions which represents power difference, gain difference with respect to cell site antenna, and gain difference with respect to the mobile antenna. Clear? So that finally the path loss is also affected by distance. We can say that the path loss is also affected by distance and height of the antenna. Clear? This is about the phase difference between direct path and reflected path. Clear? This is the final expression. Okay, thank you.